I will be speaking about tools around the ecosystem that are used to make things work in production and large-scale applications mainly. We already spoke about some of the tools in the Polo server, GraphQL Playground, Hasura, which is a GraphQL engine. I'll intentionally not be talking about GraphQL engines today. So let's go ahead in this thing. Awesome. About me, I write code mostly for fun. I like to play football, PlayStation, and in real life. I'm currently working with Prisma on a lot of cool stuff and open source software. I think we're kind of building the future of software development, so do check us out. You can find me on Twitter and across the internet with my handle. So my aim from giving this talk is to cover the width of the GraphQL stack, because once you start diving into the GraphQL ecosystem, you'll run into a lot of libraries that solve some problems. And I will go through the width of that, and some of the terms would be specific to GraphQL, and this talk is kind of incomplete by design. And I think we can make this an interactive session, and whenever you run into something where you have any doubts, please feel free to ask during the talk itself. I also aim to save you a lot of research time when you run into something weird that's happening in GraphQL land when you're actually working on stuff. Just going through this talk will tell you about different things, different tools, and you'll be familiarized with them, and it will be easy for you to know which part of your ecosystem sits where when you're actually working with stuff. I also want to talk about the challenges in maintaining open source software. This is irrespective of GraphQL. Open source takes a lot of effort everywhere. In context of this talk, I will speak about some challenges in some of the libraries to get you excited about contributing back. So I'll talk about the real problems that some of these tools are facing, and you can be motivated to come back and contribute to those things back. There's also a human challenge in writing open source software, because people who maintain software are just like us. They also have problems, and we should empathize towards that. And I also want to start a channel where we can talk, and if anyone of you wants to get started on contributing back to open source software, this is an ongoing discussion. You can talk to me during the talk, after the talk, and read me on the internet. My DMs are open. Awesome. Let's briefly talk about GraphQL. We already had a very good introduction. We have one endpoint for all data as compared to REST, and we teach our server to resolve each field somehow. So let's not go into the details of how that works, because we've already seen some demo. Let's keep it at an abstract level right now. But what we get out of this is a contract between the client and servers. The client can be a server application, or a web application, or a mobile application. And when we have this contract, which is the schema definition language, which is describe your data part of it, which we saw in the first talk as the type defs. Your client can do a lot of cool things with it, so that you don't shoot yourself in the foot. One of them is that once you have this contract, you can statically analyze your queries and see if you're making a query that is not valid against the schema at runtime without even running a query. And you can also pick your queries up while you're writing code, optimize them using a compiler or something, and then you don't even need to write optimized queries anymore, which I strongly recommend not to do, like if you can write optimized queries at the first place. And then you can also get type safety, because you can write some code on the client side, and in your CI, you can test it against the contract, and if it fails, you can fail your build, so that you never write code that tries to access a type or something that does not exist. Awesome. So SDL is something that comes from the spec. We'll also talk about GraphQL spec in a while. And SDL basically defines the capabilities of a server, and it is the contract that is shared by server and the client, and so that they're on the same page. Awesome. And then once you have the endpoint in place and the contract in place, which is the STL, you can ask for a query and you get predictable results. It started at Facebook, originally around their mobile application development, because the problems with REST come out at the scale of Facebook when they have mobile applications, and 1 year down the line their product manager comes up with stuff, and as Akshay pointed out, we have overfetching or underfetching, and at Facebook's scale, which is like used by more than 2 billion people, you can't really manage the backend because you have to serve so many versions. You have V1, V2, V3, V4. That happens in all the REST companies. We all know the problems that are there with REST. And GraphQL, why it's taking up like so fast is that it solves real industry problems, because we all are aware of these problems and we somehow manage it so far by adding versions and code. And like, I think it's taking as fast as React did in its time, because React also solved some industry problems that are there in frontend, and no one tried that kind of an approach, and that's how it's going on. So GraphQL was open sourced in 2015, and this year is a very interesting point for GraphQL, because now it has been open source for as long as it was closed source within Facebook. It started in 2012 as an internal project, and the thing that was open source was a language agnostic spec, which is also transport agnostic. By language agnostic, I mean that spec is just a document that defines how a GraphQL server should behave, and by transport agnostic, I mean that it is not necessary to transfer the queries on HTTP. It can be gRPC, it can be inter-process communication on the same machine. You can natively embed GraphQL in your Android application, then make it talk to SQLite, so the transport does not matter. So let's talk about what exactly was open sourced by Facebook and talk about that a bit. So they open sourced a couple of things, and one was the GraphQL spec, which defines the behavior of how a GraphQL server should behave. And the other thing that was open sourced was a reference implementation in JavaScript. So this is very important, because Facebook did not, unlike React, Facebook did not open source their GraphQL server's code. Their GraphQL server code is written in PHP, and that is not open source, it is closed source. They have a reference implementation and a spec. The reference implementation is used in production by Facebook, but not on the Facebook product. It's used on other products, so we'll also come to that hopefully. Awesome. So let's move towards the ecosystem, and I'll be talking about the first half of things, which is graphql-import, config, CLI, tools, binding, and VSCode GraphQL. Below the line are the things that some of them we already saw in Apollo client and Apollo server from Akshay's talk. We also saw GraphQL playground, and these are the things on which I am working on recently. And let's just dive in to see the problems that are there and the problems that we solve. So Graphql-import is one of the libraries that solves a specific problem. So spec defines the STL, that this is how you define types, but spec does not talk about any import system. It does not say anything about that. And GraphQL is one of these technologies where industry like really adopted it in a very early stage, and a lot of things were not there. And one of them was like, if you want to combine a few GraphQL files for some reason, there was no spec for it. And Graphql-import is a library that helps us achieve that. Technically, the way it works is it reads this comment-like thingy, and using this, it imports a type from a separate file and just returns one giant string in memory, so that you can logically define your code in different files, but still get the benefit of like the whole ecosystem, which supports one giant SQL file. So good things about this project is that it has the intelligent auto support system, auto import system. So you can just specify import start from something, and it will only import the types that are used in this particular file where you're importing from. Bad thing is, from my experience of talking to a lot of people who use GraphQL, is the comment syntax. So when we were introducing this thing, we used the comment syntax because it was already there in the spec. We did not want to introduce something that is not there in the spec at all. We wanted to talk about this thing, and we are kind of hoping to get this upstream into the spec. We did not want to introduce a new token or something, because then we have to have an additional transpiling step, which we have to teach everyone, and then we have to unteach everyone once this goes into the spec. So people are kind of confused, they somehow remove it sometimes if they read a tutorial or something. And that's one of the challenges as well with this project, this particular project. Other challenges about this project are like, the spec is also evolving, and we need to make sure that we support the upcoming tokens and syntaxes from the spec into this, and that requires a human effort. There can be type collisions from different GraphQL files. Two separate files can give you the same type, and you have to make a decision on what to do with it. This library also already makes a design decision on that, and you can have cyclic imports where A depends on B and B depends on A, and this library takes care of that as well. But there's a lot of open issues and stuff, so I recommend it to check it out and get in touch with me if you want to get started with stuff. Awesome. So any questions so far about?
So with when you import, the resolvers also get imported, corresponding to the scene?
This is about the schema definition language. So resolvers are not there at all right now. This is about just the contract part of it. So we are not in query zone right now. So there are like, the spec defines two things. One is the contract, which defines the contract between the client and the server, and we're just talking about that right now. The other part of it is called executable queries and executable part of things, where you can run queries and mutations. We're not talking about that right now. So GraphQL-import just works with the STL part of things, and that was an excellent question. So any other questions about this and other things so far?
It looks like it's transpiled, right? Like at the end of the webpack loader or something?
No, so this is not transpiled right now, but there's also a transpiler available which can transpile this. So these are two separate projects which follow the same semantics, because the ecosystem, two different people made this library but they spoke to each other, and there is a web loader that uses the same syntax that can work. This particular library is not a web thing. You can use this on server side as well, and you can use this dynamically as well. It doesn't have to be static. Awesome. Any other questions? Move on then. GraphQL config. So GraphQL config is an attempt to unify the configuration of GraphQL projects. Since GraphQL is language agnostic, a lot of people have implementations of GraphQL servers, which is the equivalent of GraphQL.js, which Facebook came up with. Like all languages have stuff. Python has Graphene, and Ruby and Haskell, and everyone has their own implementations of it. And GraphQL config is an attempt to unify the configuration for them. So it provides a way to specify the schema, the endpoint, and some sorts of extensions that different tools can use, and your GraphQL system works. And since multiple tools speak this thing, you don't have to specify parameters on other tools. So we'll come to this, because there will be some CLI tools, VSCode extension. You don't have to specify the schema again and again, because if you're making changes to something, then if configuration is not unified, you have to make the changes everywhere. In this case, we'll have just one configuration that will be supported by all the tools. So the good thing about this project is that it is supported by a lot of tools, so you can have multiple GraphQL servers running in different languages that can still use the same configuration file. Bad thing about this project is my personal opinion that it has too many variations. It supports YAML and JSON and array of projects or a single project, and whoever is implementing this in their particular tool has to tackle a lot of cases around it. So the challenges are around this adoption. New tools which come into the GraphQL ecosystem should maybe import from GraphQL config and have optional parameters as well, so that it becomes easy to drive the ecosystem forward. And the other thing is simplification, where I think we have too many variations and we should like lock down on some particular file format. This particular slide was super confusing, I am aware of it. We will look into graphql-config later in this presentation. Awesome. Then GraphQL CLI is a CLI tool that is also made to make the developer workflows easy, and you can install it simply by npm install -g GraphQL CLI, and then you can run commands like graphql-create, and it will give you interactive questions on what you want to do. And what it does for you is generates the boilerplate for you, and you're already good to get started. Then you can just run npm start, and you have a GraphQL server running, which you can modify and move on with. GraphQL get schema is one of the commands that is provided by GraphQL CLI, using which you can query the schema of a live running GraphQL endpoint, and you can use it on your client to do all the static typing and optimization stuff that I spoke about earlier. GraphQL lint is something that you can run against your client, and it will look at the live server and see if you are running a field which is not there or they are not in sync. So it will stop you from writing invalid queries. You can run GraphQL lint in your CI, and in your CI you will know if there is some code that cannot be executed against the server, because there is a contract between the client and the server. Another awesome thing about GraphQL Code Gen is that it supports code generation. Since you have a GraphQL schema, you kind of know roughly how your resolvers or your some subset of code like types in TypeScript would look like, and you can just generate off it now. And that is provided by GraphQL CLI. It is also configurable. Suppose you are using some language other than TypeScript, you can write your own generator, and you should be able to like generate a lot of code, and then you don't need to like write that code and maintain that code anymore. Whenever your schema changes, you can just write GraphQL Code Gen, and it will just generate stuff back to you. This is one of the tools that supports Graphql-config. So commands like get schema, code gen work without any parameters if a GraphQL-config file is present. If that file is not present, then you can also parameterize it and manage stuff. But this is where GraphQL-config becomes more stronger, because you don't have to do it again and again in your CI. You can just define one file, and then you don't need to give any parameters anyways. And this tool is language agnostic. It's written in JS, but it can be used to spin up and do stuff in a lot of workflows. All the languages support this thing. Bad thing about this project, it's a star because it's not necessarily a bad thing. There are some open issues that need some love, and that's again where I can like, help you get started on this stuff. I see one of the challenges about this system is a powerful plugin system. It's there right now, and you can write your own generators, or you can also augment GraphQL CLI and add your commands to it. But so far the ecosystem hasn't picked up around this, and people are not writing a lot of plugins like with Babel and other things. So we have to like drive that forward somehow. Awesome. So any questions on this so far? Awesome. GraphQL tools. This is one of the exciting projects that makes a lot of stuff happen. So originally, as we spoke about GraphQL.js, which was the reference implementation open sourced by Facebook, there you have to define all the types and resolvers, and it's a lot of code. What we saw in the first talk today, where we define type defs and resolvers in Apollo server, internally that is using GraphQL tools. So GraphQL tool is the code generator which converts those type defs into actual GraphQL objects, because the type def is nothing but a string unless you convert it into actual JS that is executable and define the schema. And GraphQL tools is where all that magic is happening. GraphQL tools also has this thingy called schema stitching. Using schema stitching, you can combine multiple separate GraphQL servers into a unified endpoint, and this has a lot of advantages. So one of them is architectures. Yeah.
So multiple means
you can have
physically different servers.
Yeah, you can have a code written in Python, something running on Hasura, something running on Prisma, something running on GitHub. Maybe they have a GraphQL API. You can combine all of them, and you can use GitHub's authentication system and provide data from your data source. That is something that GraphQL switching does. And this is the next point. Like it makes architectures like microservices possible in GraphQL easily, where you have multiple services that have contracts within each other, and you can do that in a type-safe manner. Apart from this, it supports, it is based on a concept of schema delegation. So suppose you have an Express server running and you have an incoming GraphQL query, and you are just aware of the schema. Like suppose you use get schema to download the schema. Now you have a query and you have a schema, but there is no GraphQL server here, it's running remotely. So there is a function provided by GraphQL-tools called delegate to schema. You can just give it the schema, the endpoint, and the query, and it will execute the remote server for you locally. And based on schema delegation, there is also something called GraphQL bindings, which we'll come to in the next slide. But broadly, you can execute queries against remote GraphQL schemas, or you can combine GraphQL schemas together. And this is provided by delegation and schema stitching. The bad thing about GraphQL tools is that as of now, it only exists in JS. And there's a lot of, I know that all of us are JS developers here, so I might not be appealing on this one, but currently it looks like GraphQL is a JS heavy thingy, but actually it is language agnostic, but it's being brought forward by the JS ecosystem. And the reason for that is that it makes writing front-end so easy, and front-end developers are the ones who are actually driving it forward. But this is a bad thing, and we should work together and have GraphQL tools implementation in other languages as well, because a lot of things are possible with the challenge would be implementation in other languages. Any questions so far?
Are there any other libraries that do something similar to schema switching in other languages, even if they're young projects?
Not that I'm aware of.
Nothing yet?
No, nothing yet. Not that I'm aware of. Because schema switching is also relatively new. I think this got stable only 3 or 4 months ago.
Yeah.
And there are a lot of ideas. There are some blog posts that explain how this actually works. But I am not aware of any implementations in other languages so far.
Also, another question, does the schema switching implementation support subscriptions yet?
Yeah, it does. Delegate to schema supports subscriptions, so
Okay.
we can do this.
Oh.
So, a note on subscriptions, as I mentioned before, that GraphQL is language agnostic, and HTTP does not need to be the only mode of transport. So you can also use WebSockets, which just makes running live GraphQL stuff possible using WebSockets, and those are subscriptions, and they're already supported by GraphQL. Awesome. Any more questions on this? So let's talk about GraphQL binding. As I mentioned that this is an implementation of schema delegation. So think of GraphQL binding as an auto-generated auto-generated SDK for your API specifically, and whenever you make changes to your schema, you can re-auto-generate this SDK, and this really makes developer experience super easy, because for your specific API while writing code, you start getting auto-completion, and you get a custom SDK that turns stuff like db.query.user, where user is something very specific to your business, and it supports code generation. It's built on top of schema stitching, and you can just generate a lot of code, and in the end your resolvers will just have this thingy. And how do you generate it? You write new custom binding, and you just give it the endpoint, and you'll get a DB object, and then you can just start using it in your resolver. So you don't have to write all the find logic and filter logic and relate stuff. All of that would be kind of generated. What this really gives us is amazing developer experience and type safety, because if you're using TypeScript, you get auto completions, and if you query a field, you will immediately know that it does not exist in the backend, because TypeScript will complain at compile time, and it makes very hard to write code that will not execute at runtime. Again, the bad thing about this is that, to my knowledge, it only exists in JS, because schema stitching only exists in JS, and we need to like move things forward a bit and see if we can implement things like bindings in other languages. Although it is still very young, and we still know that a lot of companies are using it at scale, but we still don't know all the problems that are with it. It's just one repository that has some issues, and it works for a lot of people, and we still, it's a young system. The challenges that this provides to you is an abstraction overhead. As software developers, we have to count the cost of abstractions. So if you're writing any software, you think in terms of any library that you would be using and how far it takes you away from your database or something. And it's like very far. So you need to think about the abstraction overhead that it has, and how do you get the query that's actually running against your database, and that sort of overhead. And that is something that we are actually actively thinking about as the community. And again, I would like you to join the issues and discuss stuff and try to use this stuff in production. In terms of resources, this URL, I'll share my slides later, is like an implementation of how you can make something like a custom binding for your GraphQL endpoint. And that's like 20 lines of code, not much. This is not actual code per se. This is just in Carbon app, but the original code actually looks like this. So any questions about bindings so far?
Does it play well with TypeScript?
Yeah. GraphQL binding supports TypeScript, and that's where you get all the code gen magic of you can generate types for your actual API, and then you get auto completion for your actual API, and you can at compile time know that this query will not run in production if you are like moving fast and backend teams are separate from frontend teams, stuff like that.
So this binding is supposed to be used away from the real GraphQL server.
No. Bindings can be used in a GraphQL gateway. That is the main purpose of it. So suppose you have.
Can you take it all the way to the client? The browser?
No. You can't run bindings in the browser. So not that I'm aware of.
How does this compare to having a IDE plugin that also gives you the autocomplete and not code gen magic obviously, but just the the autocomplete and the type safety in the GraphQL string that you're writing? You know what I mean?
Yeah, I understand. I completely understand. So the difference is that this, first of all, would be much smaller than writing original queries in terms of size of the thing, because query is like super huge, and this is a JS object which is like a smaller reference to it.
Right.
It's not super different, and this also supports a way out, so you can have db.request and you can actually pass in any GraphQL query to it. You don't need to use db.query if you want to do something super crazy, and there's an escape hatch already built into the system. But it's all about the developer experience. And we'll also come to the IDEs.
But this also adds an overhead at the runtime.
So it really does not, because the transformations are super small. It's not doing a lot of things there. It's just passing on the incoming object to its implementation details, but this does not do too much. GraphQL resolvers have a fourth parameter, that's the info object that contains the AST of the incoming query, and this just passes it on to the original server. There's hardly anything that this does except for providing a nice API on top of it. There's no dynamic stuff that's happening here. What's bad about this is that this happens over HTTP. So if you are doing service-to-service communication, then HTTP is not the best way to do that. But yeah, that's where I said that there are abstraction overheads, and we are aware of it, and we are thinking about it continuously. We want to support multiple protocols of bindings and stuff.
But ideally, the way of using this is not you will not copy paste a query from GraphQL and then think about that query here, because because you're using this to write a gateway component more than a front end component.
Yeah, we know. Graphical query is different from this. It looks similar-ish,
Right.
but it's not. Yeah, I mean, in the end, what gets passed down is the same thing,
Yeah.
but you don't mentally you don't think like this is the GraphQL thing and this is the thingy that I'm using. But this happens mostly on the server side of things, and GraphQL is mostly used by the client side people, content people, and that's where like the ecosystem lies right now. Awesomeness. Any more questions about binding and stuff? Alrighty. Move on. Now the VSCode GraphQL thingy. So this is something that got released very recently in GraphQL Europe. This was one of my first projects at Prisma, and let us talk about it a bit. So first of all, it's built on top of something called a language service protocol. Language service protocol is a specification made by Microsoft, and the problem it intends to solve is, as of now, if I want GraphQL support in multiple editors, I have to write something that works roughly like a compiler in that editor, and then it can provide you auto-completion for your specific thingy. So basically, to get something to n number of editors, you have to write the same thing n number of times, which is a lot of overhead. And language service protocol makes it possible for editors, which becomes the client in this case, to talk to a server, which is a language service server, and you can use one server against multiple clients. And this is basically the spec for the client and the server of any editors that want to implement this thing. So you can write one service in any language that can be consumed by multiple editors, provided they have the implementation of the client. The problem is still there. You still have to implement clients for the editors, but you don't have to implement the compilation logic and everything. Another advantage of this is that you can use this language that has the tools to compile a language, and you're not forced to write some language. For example, IntelliJ, traditionally you had to write Java for everything. It sucks. And VSCode GraphQL is an extension that's based on language service protocol, and the original project is started by Facebook. It's called GraphQL Language Service, and we use that to provide these services. There are already open source client implementations for all major text editors like Vim and Atom, and we just need to integrate them, and we can get language features with all these languages. This is not just VS Code for GraphQL, it's VS Code for everything. We just need to build it. Awesome. This gives auto-completion, highlighting, and linking in VS Code against a real GraphQL server. So while writing code, you can be sure that this will execute in production. The good thing about this project is that it reduces context switch. You don't have to write something, go to browser, test it, then it runs, because at the editor level you know that your query will work. Bad thing is that edge cases are there that need a lot of love right now. This project is still very young, although it's being used by a lot of people right now. But there are some cases which don't work or which work in an unexpected way. For example, one of the challenges that are there in this project is that all the way on the front-end side, you can have multiple GQL tags, as we saw earlier today, which could be talking to different schemas in the backend, and you don't know deterministically which schema or which API this particular thing is talking about. So as of now, the extension takes a guess, and sometimes it's wrong. It's not deterministic, and that's something we are actively thinking about. And upcoming in this extension is something like Playground or Postman for RESTland within the editor itself. It's not live yet. I'll show you a demo. But after that, you will be able to write React code, and inside your editor, you will be able to execute GraphQL queries against your local server or any other server, and you will be able to test them. So that's like even reducing the context switch further. So let's try and see how it goes. So this is running my development version of this extension, so things might crash and burn, it might not work at all. So that's a disclosure. Yeah. So this supports a GraphQL-config file. The extension requires the GraphQL-config file to exist, and then it kicks in. What it provides to us is a lot of stuff, starting with syntax highlighting in a generated code. By the way, this is a schema generated by Prisma for a database, and that's like 1,400 lines of code for you, and it provides auto completion within this. It provides syntax highlighting inside GQL tags, and if you make a mistake, I hope this works, it tells you like you cannot query field zebra on your schema because there's a contract. You don't even need to go to your CI. You can just do this in your editor. It will just break for you. And this is the upcoming feature that's not there yet, that you have a query in your React application. This is actually like the React application that I use for my own website. This is like real production code. So these are React components, and I write sheet codes sometimes. But you can execute query, and you can give in if there are any variables here, and it should come back to the user. Awesome. Let's just reload this thing. So this is my local thingy right now. It's like extension development host, super prone to break.
This looks really interesting.
Yeah. So you can run your query within your text editor, and this reduces the context switch for developers even further, and you are super type safe across the universe, and it really stops you from writing code that would break in production, which is basically human errors in the end, which you are stopping. You can write test cases and do a lot of things. You can't stop human errors, and this is just assisting humans in writing code. So, any questions about the extension so far? Do give it a go. If you're using VSCode already, just need to install it. And if you don't have Graphql-config thingy, it will still give you syntax highlighting. But once you start writing the Graphql-config, which you can do with Graphql-CLI, you just have to do GraphQL in it, and it will help you with an interactive system like npm in it, and it will assist you in writing Graphql-config. The VSCode extension will kick in, and it will just help you out. Awesomeness. Important notes about open source software. I already mentioned this, that it's written by humans just like us. We have problems, they also have problems. You have to show some empathy, and then we need more developers thinking about these problems that are there. These are in some ways computer science issues, some ways design issues, and we need more and more people to think about it, more and more people who have worked on different production systems to think about it. So come and join, collaborate in issues, talk to us, let's see how that goes. And then generally questions about the whole thing. I'm hosting this meetup, and I would really request you to give me a lot of feedback. Best is on comments on the meetup page itself, so that we can correct it in a public fashion. But if you need to reach out to me, you can find me on the internet. This was by design a meetup which is a mix of introduction topics plus production ready systems plus crazy stuff, which is like at the edge of computer science. And I think in future meetups we will follow the same thingy, and I really need your feedback on how this went for you, what did you like about it, what did you not like about it. I'll post a type form thingy as a comment so that it becomes easy for you to give feedback. Although I prefer not to do that because having a set of questions just aligns you to answer in one direction. I would just want honest feedback on this.